Hello there. My name is Chris Brower. Today we're going to be talking about searching Couchbase data at scale with Elasticsearch. But before we do that, I want to talk a little bit about who we are and who I am. So first off, I work for a company called CenterEdge Software. We were founded in 2004, and we provide software solutions for the entertainment industry. So whenever you go to somewhere with a roller coaster, or if you end up in a jump center, or you find yourself near one of those weird looking upside down houses, a lot of those places are running our software to complete their business solutions. Now we support many aspects of those business operations. So for instance, from scheduling stuff online to booking a party, to things like waivers online. We support all of that and searching for those things online. Now, we are working on transitioning more and more of those operations to the cloud. So today we're going to talk about our waiver system that we've transitioned to the cloud and how Couchbase has helped us move that into the cloud. And we're going to talk about how Elasticsearch helped us with a problem with searching certain large number of documents. For myself, my name is Chris Brower. I'm a senior developer at CenterEdge Software. I've been a Couchbase server user since 2019, so still pretty fresh on it, to be honest. And I've been using Elasticsearch since 2017. So let's talk about today's session goal in a little bit more detail. So today what we want to talk about is we want to talk about full text search solutions. So we're going to go over how we're using Couchbase for this, how it was achieving our full text search. We're going to talk about how we were measuring those search results. And now we ended up deciding that in order to get the results that our clients wanted, we ended up using certain parts of Elasticsearch. Now, if you use Elasticsearch, you're also going to have to figure out how do you get that data from Elasticsearch into Couchbase. And so we're also going to cover how to get that Couchbase data into Elasticsearch using a Couchbase connector. So my esteemed colleague Brant will be helping me out with that right after I cover some of the Elasticsearch parts. Now, along with that, we're also going to give some final thoughts at the end regarding certain analyzers that you may need or certain search elements that you're looking for, where Couchbase may likely have what you're looking for right out of the box. So if it does, there is no need to do all this. You can just use what Couchbase offers right out of the box. However, in certain situations, you may want to be using Elasticsearch. And so we'll go over why or why not this may be useful for you. So first off, full text search. What is it? So full text search is a way to examine all the words in every stored document, trying to match search criteria. So let's say you have a book and you have a page, and in that page you're trying to find all the instances of the word the. Now you could do that by scanning just that one page. However, this gets much more complicated with large amounts of data. If you choose to go word by word and searching through them, you will be there forever looking through the Library of Congress trying to find all those instances of those words. Now, as we work on these problems, trying to find out if we're searching well, not only is the speed of those results important, but also the quality of those results. And when we talk about quality results, we're going to be talking about precision versus recall. So precision is the quality of those results that are returned, and recall is the ratio of relevant results returned to the total results. So let's go over an example about precision versus recall. So let's say that I search for the word Rick, and I get back the words Bobby, Marcus, and Steve. We'd say precision is low. But if we got back Rick, Ricky, and Ricks, we'd say precision is high. All those results match what we're looking for. However, let's say if we search for Rick and we get back Rick, Eric, Steve, Marcus, we would say that recall is pretty low. So as we searched on how to get the best solutions, we dealt with problems like this, where we could get very quick results, but our recall was really low. Or we'd get quick results, but our precision was low. Or our search would be medium speed, and precision and recall were both medium. And so there's this big payoff game that you play. So what we were doing is we were searching across millions of waiver documents, 10 to 15 million. I don't remember what it started as, but it's a good number that was up there. And Couchbase supports many, many things. And we were using certain token analyzers to look across these documents. However, we were having a hard time getting that speed based on the analyzer that we were using. So we're trying to get these specific, Google-esque results. But we weren't able to do it while still maintaining a fast response speed. And that's where these items came into play. All right. So why Elasticsearch? The really big one for us was analyzers. The big one being name search. And we'll get more into that later. That being said, for you, Elasticsearch may not be what you're looking for due to things like infrastructure. So if you choose to do this, you're going to have an Elasticsearch instance up, and you're also going to need some way to get that data from Couchbase into Elasticsearch. All right. So let's talk about querying Elasticsearch. We're going to go through and give a very quick intro, and then we'll follow that by a full text search query review. All right. So for those not familiar with Elasticsearch, a very quick explanation. So Elasticsearch, it is an inverted index structure, and it uses Apache's Lucene in order to return and search results. Stored documents are also available via API. So just like if you wanted to get or update or add new items, you do that all via the API. Now behind Elasticsearch, and what's going to come into play today, is we have index writers and index searchers. So later, when Brant talks about how to bring data into those indexes, how you write those out matters, because you're going to be searching across them later. What properties you care about, what needs to be stored tied to these properties. So you may want the whole document, but you may want to only care about indexing these 3 properties, things like that. But also those index searchers that will look across those indexes. Now, if you heard that first part where you said inverted index, what is that? Let's talk about what an inverted index is. So an inverted index, basically it's a way to store where the location of words within documents are marked. So you'll notice in this example, I have the word hello, and that's in document 1, and that's word 1. And then I have everyone, document 1, word 2. Then I have things like this article, and you'll notice on the word is, that's in document 2, word 3, but it's also in document 3, word 2. So if you thought about how this may be stored across many books, is you could have things like the book, the page, the paragraph, all these different parts of that index where you could tie what it's into. So if someone searches for the word the, you could quickly return what all books, what all pages, etc. contain that information. So it's a quick way to look back from certain words to find that information. Okay? So regarding using Elasticsearch, let's say that I have on my Elasticsearch instance, I have tons of waivers, right? And I want to be able to get those waivers. Now you can make a typical, GET request for those waivers, but you can also search those waivers. And that's where our full text search solution comes in. So right here, let's say that I wanted to search waivers and I only wanted to get all waivers. I don't want to eliminate anything. Just give me all the waivers. In that situation, I'm making this request right here, just to get an example of that query syntax, where I'm saying match everything. Give me the whole deal. Now, let's say that I wanted to get more specific and only return, let's say, waivers where the first name or last name had the word Bob in it. So as an example, you'll see in this document, in this query search, I'm going through and saying, okay, match any of these. My query is for the word Bob, and I'm looking in the fields, first name and last name. Now, let's say your document had something like a child attribute. So it was signee.firstname, signee.lastname. You could specify those fields there. It doesn't just have to be, one property down, those kind of things. All right. So let's get in some more nitty gritty kind of queries. So in this example, I'm going through and I'm saying, I want to get back a name. And this is where that analyzer comes into play. Because what I'm looking for is I want to look for Mark Smith, and I want to look across fields, and I'm going to look in first name and last name. So for instance, let's say someone goes to search for a name, right? And they type Mark Smith, but they type it M-A-R space, and then K Smith, or whatever else. This is where that name analyzer comes into play. So what it's looking for is it's saying, all right, so you have Mark Smith. I have the first name and the last name. So in our waiver documents, we're looking for the signee where they have that first name or last name. And I'm going across those two fields to find that name. So what's nice here is that, let's say that name is incorrect or the search query is incorrect. That analyzer is going to help us look across both those fields to try to match the name. And that analyzer is really what helped us the most here, where we could go through and have a very inspecific query, something that's not correct. Let's say it's Christopher Brower or Ark Smith, stuff like that. And it could get back those results that was most likely what the user wanted. So that's where that analyzer comes into play. Now let's say you have a situation like us where you have a document where that document has multiple names within it. So for us, we have waivers where they have a signee and they have multiple dependents on that waiver as well. So let's say they have, kid 1, kid 2, kid 3, all within that waiver. That's just one waiver for us. So here in this query, this is an example where I'm combining multiple queries to try to find the most appropriate name. So let's say I'm looking for Mark Smith, and it could be a dependent or a signee. So in this example, I'm looking for where it should match, so on this Boolean, and you'll notice this is split in two parts of this query. So the first part is nested, where it's going through and saying, all right, in the document dependents, which is an array, go through and find the one that gives me the best score, where I'm saying in this, find that same multi-match query for Mark Smith, and I'm looking across the fields, first name and last name, and I'm doing a name search. So what this gave us is a way to look across all these waivers, all the dependents, and the signee, and find that instance of Mark Smith that matched based on the highest score. Now for things like Mark Smith, we're probably going to get lots of results because there's, lots of people named Mark Smith. But then when it came to more, specific results, we could give that user the exact response they were looking for. So for instance, if you were looking for Chris Brower, you're more than likely getting the result you're wanting for. Or if you're looking for one of Chris Brower's kids, let's say Mark Brower, you can pull back that waiver very quickly, okay? And that helped us a whole bunch. Now, again, we've got the search thing figured out. We've got a way in Elasticsearch to look across names. However, the thing is, we still need that data in Elasticsearch, right? So the thing we're going to cover next is you want to use one of the analyzers within Elasticsearch. How do you do that? Brant's going to jump on next, and Brant's going to show us how do we get data from Couchbase into Elasticsearch, keep that data up to date, and make it where we can use this so we can do full text searching at scale. Thank you so much. Brant, go ahead and take it away. Thank you. Thank you.
Hi, everybody. I'm Brant Burnett with CenterEdge Software, and I'm going to talk to you about where the rubber meets the search and other bad cliches. So we're going to kind of go through, starting from the stuff Chris talked about, and go through, if you're in one of these scenarios where the Couchbase full text search doesn't quite meet all your needs, what can you do to wire it up to something like Elasticsearch without it being too much more difficult than the super simple things you can do to wire up your data into the Couchbase full text search. So I'll talk a little bit about me for a moment. I'm the systems architect at CenterEdge Software, and I've been a Couchbase server user since 2012. I'm also an open source Couchbase contributor. I have several different open source projects for users of Couchbase and also contribute some to their SDKs. And I'm a Couchbase community expert, which mostly means if you post something to a forum there that I pay attention to, you're probably going to have the misfortune of getting a response from me. So let's talk about the Elasticsearch connector. The Elasticsearch connector is one or more separate Java processes that wire Couchbase to Elasticsearch. And they're actually officially created by Couchbase. This is not some third-party open source project. It is an official thing you can do. And so these separate Java processes stream data from a single bucket. Now, you can stream data from more buckets, but you need to spin up more Elasticsearch connector groups. So you need to spawn more processes to stream data from more buckets. And it streams the data to a single Elasticsearch cluster. Now, note that this is happening with the DCP streams. I believe it's data change protocol. So that's kind of the under the hoods protocol that's used for the cross data center replication in Couchbase Server. It's used for keeping the nickel indexes up to date, the Couchbase full text search, analytics. All this stuff is based on the DCP protocol. So you're getting the same sort of quality of speed of data flow upon mutation with the Elasticsearch connector that you do with any of the other Couchbase services. You can filter the documents that are coming out of that bucket. So as mutations happen, you can throw away the mutations it doesn't care about, and then it can assign those mutations to different indexes. So a document of type customer can go into a customer index, and a document of type product can go into a product index. And it does keep track of state between restarts. So if your Elasticsearch connector dies and you crank it back up again, it will pick up where it left off. It might resend a few documents, but you're not going to lose any data during that process. And so what does this data flow look like? So this is a very simple data flow diagram of how the data flows. And there's a few key points I want to point out about this data flow that will kind of be gotchas when you're setting this up. So this is a data flow for a single group of Elasticsearch connectors. So this is a case where I've got one Elasticsearch connector configuration and I'm running two processes to do it. And so you could spin up more than one group by spinning up more processes in different places. But this group is responsible for streaming the stuff from that single Couchbase bucket to that single Elasticsearch cluster. Now, the first thing to note is that it is splitting between the two connectors by vBucket. So vBuckets are, I think it's virtual buckets. There's typically 1,024 vBuckets to one bucket. Any given document lives in one vBucket. And any given vBucket is assigned to one connector in the group. You can run a group of 3 or 4, but it will only be assigned to one connector. What this means is that this is not giving you high availability on your connector. If the connector 2 of 2 goes down, half of your mutations will be backing up and not making it to Elasticsearch, while the other half go through connector 1 of 2. What it is giving you is horizontal scaling. As you spin up more connectors in your group, then you're going to start getting a better speed getting your mutations through. So the higher the mutation rate on your bucket, the more connectors you might want to spin up, or the more resources you might want to give to your connectors to help them keep up to date with the mutations streaming. The second thing is that each connector is responsible for picking the index and sending it onto Elasticsearch. So what that means is you need the configuration to be consistent. Every connector in the group must have the same configuration. If it doesn't have the same configuration, then insanity is going to follow, because you're going to have one connector sending things to different indexes than the other, and it will go crazy. On top of that, part of the configuration is how many connectors are in the group. If they don't all know that there's 3 connectors in the group when there are 3 of them, then they will overlap vBuckets or drop vBuckets on the floor, and you'll also get craziness going to Elasticsearch. So keeping that configuration consistent is key. Now, there is support for using HashiCorp console. I never have figured out exactly how to pronounce that one. So if you were to use that service, it helps orchestrate that. Also, I'm going to give you the example, which is what we use, which is using a Kubernetes stateful set, even though they're not really that stateful. But using a stateful set provides the logical structure that you need, and you can actually have that configuration much more carefully managed for you using config maps. So we'll get into that example in a little bit. And then the final thing to note is that when it picks an index, the Elasticsearch connector can only send a document to one index. So there is no facility for saying, oh, if I get a customer document come in, I want you to send it to the customer's V1 index and to the customer's V2 index, because I'm currently doing some A/B testing on my indexes. If you want to do that, you'll have to spin up another group of Elasticsearch connectors. That's one of the things about this situation that is more difficult to deal with than with the built-in Couchbase FTS, is how much work it is to get data to additional indexes like that for A/B testing. However, the one nice thing is whenever you spin up a new connector group, it does immediately start by streaming all data from the Couchbase bucket. So within just a few minutes, it will bring your Elasticsearch cluster up to speed. I believe in our case, we had, I want to say it was 15 million documents at the time when we were looking at moving to Elasticsearch, and it streamed them all over in under 10 minutes. But it might have been more than 15 million. My memory is getting a little foggy now. So that's kind of what the data flow is and the things you need to watch out for. Spin up multiple groups, keep them the same size, keep them with the same configuration, and then magic happens. Another cool thing about Elasticsearch is it's actually keeping a copy of your entire document in the Elasticsearch cluster, which means that when you get search results out of Elasticsearch, it can give you back the whole document at near zero additional cost. You don't just get the document key and have to turn back around and pull it out of your Couchbase bucket. You're getting the whole thing, as long as you're willing to accept a certain degree of eventual consistency. It might be a few seconds behind the data in your Couchbase bucket. So now we're going to get into the demo part. So this is the part where I embarrass myself thoroughly trying to show you some examples of how all of this works. So let me switch screens here. And let's start off showing you the Couchbase cluster. It's one node, but this is what I've spun up in Docker on my local laptop. And I kind of show you what I've got in place. So first of all, I got my default bucket. This is my documents that I want to be able to search. So if I pull up the documents, you'll see that I've got it populated with a bunch of fake customer documents. They don't have a lot of data in them, but I got a first name, I got a last name, I got my customer type, and then I've got an address. So I'm going to show a slightly more advanced example here, which is what happens when I want to index this, but I very specifically, for compliance reasons and privacy reasons, don't want the address to get over to the Elasticsearch cluster. So I want the first and last name and the customer ID over there, but I don't want the address to ever be known to Elasticsearch because maybe it's on a less secure architecture than my Couchbase cluster, or there's encryption reasons and protecting that PII. But this same process could also be used to simply mutate the nature of the document itself to make it more searchable. And it could also be used to help deal with size. If you don't need all the data in Elasticsearch, and so you're trying to keep the size of that cluster down, you could use it to strip out like large blob data in your Couchbase documents or things like that. So for that scenario, I find the simplest thing to do is actually to use Couchbase's eventing infrastructure. So the eventing infrastructure, again, built on DCP streams, is good for taking all mutations going into one bucket, in this case, my default bucket, and doing things with them and then taking the documents and putting them somewhere else, in this case, in my search bucket. So what I've done is I've already created and run an event called my customer search event. And so if we look at the settings on this, it's deployed to stream from the default bucket. It stores its status in the eventing bucket for all of its status metadata goes there. Settings are basically default, but then I alias here that the bucket DST for destination is my search bucket, and I can read and write from that bucket. So now if I look at the actual function itself in JavaScript, you'll see it's got two functions, onUpdate and onDelete. So every time you create a new document or update an existing document, it's going to trigger this onUpdate function. Doc will be the JSON object of the document itself. Meta is a JSON object that has details about the document, most notably its key or its ID. And so you see here in this function, I'm saying if it's a customer document, important, I don't want to stream every document of any kind that goes into my bucket. I only want my customer documents. Then I delete the address property from that document, and then I store it in my destination bucket using the same key. So this should result in a copy of every single customer from the default bucket existing in the destination search bucket, just missing the address. And then additionally, I have onDelete here, so this function will run anytime I delete a document. Now, the one tricky thing, and this has to do with how DCP works under the hood, I don't have access to the actual document contents in a delete event because guess what? It's already been deleted. What I do get is the metadata, so I can't get the ID. So here you see I'm doing a regex match on the key of the document to confirm it's a customer document, and if it does, then I'm firing a delete over to the destination bucket using that key. So that will delete any documents that are customer documents. When they're deleted from the default bucket, it will delete in the other bucket. And then once I deploy this and tell it to run from all existing data when I deploy it, it will stream all that data across, and I end up with this situation here. I've got the same number of items in these buckets. I can come in and hit documents here, and we can see that they all have the same keys. And we look at the document contents, we see it's the same document contents, but missing the address. So that's a really good way, and you can do just about anything you can do with JavaScript, you can do in there. Short of, you can't pull in NPM packages, but you can do a lot of stuff to go in and manipulate your data in different ways. And in some of our earlier search experiments, we're really doing some pretty complicated stuff, flattening arrays and doing some other stuff like that for our searches. This, however, is completely unnecessary. If you don't need to mutate your document, just have the Elasticsearch connector pull straight out of the default bucket. So pulling out of this secondary bucket is only if you want to do something to mutate that data. So from there, the next step is, okay, I need to get these documents out of the search bucket. Those need to go and live in Elasticsearch. So how do I make that happen? So to that end, I can pull up and show you. This is an example of a TOML file. I think that's how you say that. I'm not a Java guy, and they're popular in Java. That defines the configuration of the connector. And so I'll just go over some of the key things you need to look at when you're making one of these configuration files. One, every single configuration file across a given group, this is the name of your group, should be the same except for this member number. Every single one should have a different member number. So in this particular case, I'm saying there's one total members, and this is member number one. So I'm only going to spin up one connector. But I could make this 3 and then vary this to be 1 on one instance, 2 on the second, and 3 on the third. This group name is important. This is going to be used as the persistence key to keep track of the state. So that's important for the shutdown and restart so that it knows how to pick up where it left off. So don't go changing this willy-nilly. If you change the name of it and re-crank it up, it's going to restream all your documents because it's going to have lost its state. It does offer metrics. You can configure this port here, so those can be wired to things like Prometheus or other metrics tracking so that you can monitor how it's working. It does have a Java trust store to deal with CA certificates if you're doing encrypted traffic to Elasticsearch. It's a little tricky if you don't know Java trust stores to actually get a certificate in here. But for example, if you're running in AWS, which is what we do, you're probably going to do that. But you can Google and find out how to get certificates into a trust store off Google. I'm not going to go quite that far into it. But in addition, there's a secrets folder, which is where passwords are stored. So there's a file in the secrets folder, trust store password.toml, that will have the password to open the trust store. That same folder will have Couchbase password, which will have the password to Couchbase, and Elasticsearch password, which has the password to Elasticsearch. And other than that, you're also configuring, this is how to connect to Couchbase. This is the host name, actually an array of host names, and which bucket you're streaming from, in this case, the search bucket. And then here, a metadata bucket. So let me flip back. That was this bucket here. This is the bucket it will persist its metadata in about how far along it's come so it can do its resumes. This can be the same as the eventing bucket. In fact, in our case, to keep bucket count down, we keep our eventing and our Elasticsearch status in the same bucket. I have it split here just for clarity. I would not try to use your actual search bucket or default bucket, because if you do that, then you're putting more mutations in that then have to stream through, that then have to be recorded as additional mutations, and you just created infinite recursion. And last I checked, that was pretty high on the list of things they teach you in your computer science classes in college not to do, is infinite recursion. There's some tuning for the DCP protocol. You can set this to secure connection if you are using SSL. If you're in AWS, you may need to put in a region here, say like US East 1, to go to the AWS instance of Elasticsearch. But then the key thing is the document structure here. So by default, the document created in Elasticsearch has a very slightly different structure than the document in Couchbase. It basically nests everything down one level. It has, the root of the document in Elasticsearch has a meta attribute, and then it has a doc attribute. And then the document is underneath the doc attribute. The meta has things like the document key and those other things, so that you have access to all of the data about the document. You can configure that behavior here a little bit if you want to. And then you can assign some type defaults, like ignore deletes, for example. But then the key thing here is that you define a type. And so here I'm saying I have a regular expression. I want anything that starts with customer dash to go to the index example. So you're going to want to put in at least one of these to help keep track of all of those customer documents. Now you could put in multiple copies of this section. And there's some examples in the example default configurator. But what this will do is it's going to go through and take the first one that matches the condition for any given document. That will be the index it goes to. So you could come down here and do a second one that says, okay, well, I want everything else to go to everything else and just match dot star. And customers would go to example, everything else goes to everything else. And there's various, types of matches that you can do. Like you can do prefix matches instead of regex. And then also you can take matching groups out of the regex and include it in the name of the index. So there's some pretty advanced stuff you can do there. But again, takes the first match. So every document only goes to one index in Elasticsearch. So then what happens when you spin it up? So let me actually spin up the connector and we'll see what it does. So I got a little script here that's actually launching it. This is just launching it inside Docker. So you see it's cranking up, it's figuring out where it needs to be on the various V buckets. And you see very quickly there, it wrote out 1,000 actions means that was 1,000 documents that it handled. And see, it ran it in 2 threads, and it gets through and saved connector state means that it saved that information back. So now you see we've got 1,024 documents in the ES connector bucket, one for each V bucket. So if we look at them, it's a binary document, but you can see it's the checkpoint for specific V buckets are being checkpointed in here. So that what that means is that if I then kill this process and then relaunch it, then we can see it starts up, and then it determines that there were no changes to mutate compared to its previous state, and now it's just sitting here idle. Now at this point, as long as this is running and the event is running, any changes that I come and make, so let's say I come in here and I want to edit one of these documents to have my name in it. And I save this, and now that will then trigger the event, which sends it over to the search bucket, and then you see very quickly it came over here and picked it up and streamed it to Elasticsearch. So now that document is in Elasticsearch along with all the others. So I can pull stats and see the stats. I've got 9,102 documents indexed. I've indexed a total of 9,103 because one of them was mutated. And then if I want to query it, I've got an example query here that's matching on first or last name, and I'll stick in my name and we'll see the actual query result. And of course there's SDKs for Elasticsearch for every language under the sun. But we can see, oh, I need to change my URL back to search. And we can see that there's the query, and you can see the structure of that document that it created here is available to you. You got meta, it tells you the VBucket ID, sequence, CAS, flags. I mean, it gives you everything. There's the key. And the document, here's the content of the document. So you can, as I said before, if you're okay with eventual consistency, you can deserialize that off, do your mapping, and send it back down on your API response directly without needing to go back to Couchbase again to get that data. So then a few other little tricks and things I would point out for how you might use Elasticsearch. Let me pull up my, not that one. Here is an example JSON file for a template. So what I actually did was I created a template for the index. It said anytime I create an index that starts with example, use this template. And you go through and you specify the properties on the document and what analyzer to use. By default, it's going to go through and index every single field in your document using a default analyzer. And it will automatically pick up new things added to your schema. If you add a new property to your schema, it's going to automatically pick it up and start indexing it using the default analyzer, unless you expressly disable that. So I believe, if I remember correctly, is you do additional properties false, and it will tell it, okay, don't automatically index new properties. And you could have to do that down nested through each thing in your nested document. When you get to arrays, you probably want to expressly configure the array as type nested, which allows you to do nested queries on the contents of the array. The details of that are a little beyond scope here. You can look at the nested handling inside Elasticsearch. Basically, it will index all the items in the array, but it doesn't keep any data about how the different fields are on the same item of the array versus just being present in your document altogether. But you can use the nested type and then a nested query in order to get more detailed analysis. So if you've got an array of first and last name pairs, you can analyze how they pair together rather than just presence on first and last name. The other thing is you can't really reconfigure any of these things once they're there and the index is made without rebuilding a new index from scratch. So if I wanted to change the analyzer on this first name property, I need to make a new index. You can, however, if you do that additional properties false trick, you can come in and add in a particular type onto a particular, on a new field that hasn't been indexed before. So that would generally be my recommendation with Couchbase would be to set additional properties to false so it doesn't automatically index them with the default analyzer, and then come in and add them to your existing index with the analyzer you want when you're ready to actually use them on your index. So that's pretty much it for getting the actual Elasticsearch cluster up and running, getting the analysis done, being able to search, do all those things. The one remaining thing is, okay, I just told you about all the things not to do with this configuration file. How do you make it so I don't mess that up? Because I could do it right once, but when I have to do maintenance 6 months from now, I'm going to forget all that. And so to that end, I recommend Kubernetes. It's a great solution. It makes it really easy for you to launch lots of processes, really easy to control configuration in a centralized manner using config maps, and that sort of thing. That's what we do, and it's been working great for us. So the good news is that if you go to the Couchbase Elasticsearch connector repository on GitHub, we took what we did in Kubernetes and contributed back as examples in that repo. So you can come in here and actually see how we do it. So a config map in Kubernetes can do a lot of different things, but one of the things that's my favorite thing to do with config maps in Kubernetes is if I give it data and I give it a key on a piece of data and then a bunch of content, and then I can do multiple keys with multiple chunks of content. I can mount that as a folder into my pod. So you see here, I've got log4j2.xml, and I've got my default connector TOML file, and then I can put all my content here, and it just gets mounted on as a folder in my pod for me to consume. The next neat trick, and this is specific to the Elasticsearch connector, is when it parses these TOML files, it can pull in environment variables. So in this example, we have things like the Couchbase Elasticsearch _group environment variable will come in and be your group name. This here is the default if I forget to set the environment variable. And I can do that with the member number. I can do that with the total members. And that makes it easier for me to not mess this up. You could certainly go through and make a lot more of this stuff come from environment variables too, if you so desired. But in this example, we basically kept it to those three things, which are the three things that are going to vary the most other than your indexes that you're probably going to want to configure directly in this file. So then this is a stateful set definition. So a stateful set is really nice because you get to not only specify the exact number of replicas you want to have, 2 or 3 or 1, but that becomes a very highly controlled thing that I can refer to. So basically, if I've got here, I've got my CBES group is actually pulling from my labels. And so if I look here, I've got CBES group, example group, so that's going to get pulled in. And then during startup, I can parse the host name and extract the member number. So that means if this has 3 replicas, I'm guaranteed that this environment variable for each replica will be 1 for 1, 2 for 2, and 3 for 3. And so then that environment variable is going to go in and make sure that I don't cross up any of my members in the group. I will have 1 or 2 or 3 without having 2 of them running number 1. The only tricky part is you do have to make sure your CBS total members here must match this replica count you put up here. I couldn't find a way with the current version of Kubernetes to pull that into an environment variable from this setting up top, unfortunately. And there's a bunch of other little things. For example, we have pod anti-affinity, which is designed to make sure that I don't run all of the pods in the same failure zone. So if I have a zone go down, they're not both going to go down. At least I'm only losing half. Resource limits for CPU and RAM. These are the ones that we found work for us, but you could certainly tweak those. And a liveness probe is imperfect. It's looking at that metrics port to make sure that, hey, I can still get metrics out, and it's pinging it every now and then so it can spin up a replacement if it dies. We have seen instances where the Elasticsearch connector basically gets into a non-functional state where it can't pull data, but it's still running. The process hasn't crashed, so this is still returning. So to address that, I would recommend having these metrics go out into Prometheus and Grafana or Datadog or something like that, and having alerts so that if the number of processed documents plummets, that it pings an alert that you might have a connector that's down. And then finally, we mount the configuration into the configuration folder from that config map you saw earlier. And so it puts those files in there that it needs to operate. And then we do the same thing with this as a secret instead of a config map, which we mount into the secrets folder. And that is what would have your cluster password for Couchbase and your cluster password for Elasticsearch, and potentially your certification authority if you're doing encrypted connections to Elasticsearch or Couchbase. And so all you have to do then is deploy the configuration file, deploy your secrets, which I don't have an example of here because typically you don't just write those out in the YAML file because they're secrets after all. And then deploy this and your connector's up and running. And you can just watch logs and make sure it's working. And it manages most of the heavy lifting for you. Now, one gotcha. You'll see here that in containers, it just says registry/image:/tag. This is because as of today, when I'm recording this, Couchbase still does not publish a Docker image officially for the Elasticsearch connector. They just give you binaries you can download. There is a Docker file, both a full build as well as a light that downloads it from the internet Docker file that will build up a Docker image right here in their repo that we contributed to them. And they just haven't fully automated it and run through all their support testing and all that stuff. It is what we use. Alternatively, the Docker Hub is where we have the CenterEdge copy of the Elasticsearch connector that we use. That's up there. It's open and public, so anybody could pull that copy. To which end, I will move on to actually show you some of those URLs on your screen. The first URL is for the Elasticsearch documentation that you can go through and read all their instructions and documentation. The second URL is to their Elasticsearch connector repository, which has specifically linked straight into the Kubernetes example I was showing you. And then the third is to the CenterEdge copy of the Couchbase Elasticsearch connector. I'm hoping that Couchbase will have an official copy of that up at some point. So thank you guys very much for your time. Hopefully this was informative. Chris and I are both very available for questions. Chris is something of an Elasticsearch expert. He spent a lot of time working with Elasticsearch and the queries, even before he was at CenterEdge. He's kind of the one that steered us in this direction. And I'm kind of the Couchbase guy. So if you have any kind of questions about the Elasticsearch connectors, the Kubernetes infrastructure, how we get that stuff wired together, or venting, please feel free to reach out and I'm happy to answer them. Thank you everybody very much.